Hi everyone. By the end of this video, you will have a clear idea on applications of dimensional analysis and numericals related with applications of dimensional analysis. The first application is converting from one system unit into another. When we convert from one system unit into another, the size doesn't change. When it is 1 kilometer the distance, when we change into meter, it is 1000 meter, even though the numbers change, but really the distance 1 kilometer and 1000 meter are the same, which means magnitude of the physical quantity remains the same in whatever the system unit it may be, because 1 kilometer and 1000 meter are the same distance, even though the numbers are different. We want to convert one number in one system unit into another number in another system unit. For that, make n2 the subject. When we make n2 the subject, n1 remains the same. The whole thing will go to the denominator. Then it becomes m1 divided by m2 to the power of a, l1 divided by l2 to the power of b, t1 divided by t2 to the power of c. Let's do a question. Convert 1 joule into erg. For that, we need to know which physical quantity has a unit joule. Energy has a unit joule. And the dimensional formula of energy is m to the power of 1, l to the power of 2, t to the power of minus 2, from which we will get an idea. The value of A1 in the conversion factor is 1, B is 2, and C is minus 2. And the N1 is just 1 joule. Let's see the different system units. In SI system unit, mass is measured in kilogram, which I change into gram. Meter, change it into centimeter. Second remains as second. And we are changing from SI unit to CGS unit. So the corresponding units in CGS are gram, centimeter, and second. Let's use the conversion formula. This is the conversion formula. Plugging all the numbers. N1 is 1, M1 is 10 to the power of 3, mass in the first system unit, M2, mass in the second system unit, which is CGS, 1 gram, to the power of A, which is 1. Same way, L1, 10 to the power of 2, L1, whole to the power of B, B is 2, then T, in both system units, it's 1 each, to the power of minus 2. Gram cancels. What's remaining? 10 to the power of 3 to the power of 1. Centimeter cancels. Remaining is 10 to the power of 2 to the power of 2. Second cancels. 1 to the power of minus 2, which gives you 10 to the power of 3 to the power of 1 is 10 to the power of 3. 10 to the power of 2 to the power of 2 is 10 to the power of 4. This remains as 1. So overall it becomes 10 to the power of 7. So the conversion is 1 joule is 10 to the power of 7 erg. Let's do another question where we have to convert from Newton to dyne. Newton is SI, dyne is the corresponding CGS. Let's see the conversion table is just like this. We go for the conversion formula, and the conversion formula same as before. N1 is 1, M1 is 10 to the power of 3 gram, M2 is 1 gram, A value is 1, L1 is 10 to the power of 2, L2 is 1 centimeter, and the B number is 1, T1 and T2, 1 each, C value is minus 2, gram cancels, centimeter cancels, second cancels, what's remaining? 10 to the power of 3 to the power of 1, 10 to the power of 2 to the power of 1, and 1 to the power of minus 2, all will give you 10 to the power of 3, 10 to the power of 2 together, which gives you 10 to the power of 5, because this is just 1. So the conversion factor is N2 is 10 to the power of 5. So 1 Newton is 10 to the power of 5 dyne. We move on to another question. Convert erg into joule, CGS unit of energy into SI unit of energy. Dimensional formula of energy as before. ABC values, N1 value is 1. Now we are changing from CGS to SI. So I wrote CGS first. Gram, we are changing into SI, which is kilogram. The conversion is 1 gram is 10 to the power of minus 3 kilogram. SI unit is 1 kilogram. Centimeter, 10 to the power of minus 2 meter. Time, seconds each. So what I did, CGS I converted into SI. Why? Because we want to change from CGS to SI. The conversion equations, plugging the numbers, N1 just 1, M1 10 to the power of minus 3, M2 1 to the power of A value is 1, L1 is 10 to the power of minus 2, L2 is 1, B value is 2, and time is 1 to the power of minus 2. Kilogram cancels, remaining one is 10 to the power of 3 to the power of 1. Meter cancels, 10 to the power of minus 2 to the power of 2, 1 to the power of minus 2. 10 to the power of minus 3 to the power of 1 is 10 to the power of minus 3. 10 to the power of minus 2 to the power of 2 is 10 to the power of minus 4. 1 to the power of minus 2 is 1. Same. So overall it becomes 10 to the power of 7. So N2 value is 10 to the power of minus 7. So the final answer will be 1 erg is 10 to the power of minus 7 joule. One more, where we change the universal gravitation constant 6.67 times 10 to the power of minus 11 Newton meter square per kilogram square into the corresponding CGS unit. For that, we need the dimensional formula of G, which is m to the power of minus 1, L to the power of 3, T to the power of minus 2. ABC values, minus 1, 3, minus 2. N1 value, 6.6 times 10 to the power of minus 11. We are changing from SI to CGS. So, mass, kilogram we changed into gram, meter we changed into centimeter, CGS, gram, centimeter, etc., etc. The conversion formula, plugging the numbers, N1 is 6.6 times 10 to the power of minus 11. M1 is 10 to the power of 3 divided by 1 whole to the power of minus 1. Then L values 10 to the power of 2 divided by 1 whole to the power of 3, and T values 1 to the power of minus 2. As we did before, gram cancels, centimeter cancels, second cancels. What is remaining? 6.6 times 10 to the power of minus 11, 10 to the power of 3 to the power of minus 1, 10 to the power of 2 to the power of 3, 1 to the power of minus 2. Same, 10 to the power of 3 to the power of minus 1 is 10 to the power of minus 3. 10 to the power of 2 to the power of 3 is to the power of 6. The other one is 1. So eventually we are getting 10 to the power of minus 11 minus 3 becomes minus 14 plus 6 will give you minus 8. So this is the value of N2. So the final answer will be this into 10 to the power of minus 8 dyne centimeter square per gram square. Second application, check the correctness of a given physical equation. For that, they gave you an equation, S equals ut plus half at square. Now, we know the dimension of S as L, dimension of ut together, which is u has a dimension lt to the power of minus 1 and t has a dimension t, making them t to the power of minus 1 and t to the power of 1 cancels. It becomes just L only. Now we go for the dimensional formula of half at square. Half has no dimension. Acceleration has a dimension lt to the power of minus 2. T has a dimension t to the power of 2. This minus 2 and this t to the power 2 cancels, remaining is L. So what do we see over here? Each term has same dimension. By the principle of homogeneity, the equation is correct. Moving on to another equation, the correctness of equation, v square equals u square plus 2as. Let's see the dimensional formula of each term. U square, which is velocity, the whole square, which gives you Lt to the power of minus 1, the whole square will give you L square t to the power of minus 2. We go for v square dimensional formula, same as before. V is speed, so Lt minus 1 whole to the power of 2, which gives you same as before, L square t to the power of minus 2. We move on to the last term, 2as. 2 is dimensionless. Acceleration is L t to the power of minus 2. S is the displacement, has a dimension L. So together it becomes L square t to the power of minus 2. So each term has same dimension By the principle of homogeneity, this equation is correct. The third use, derive a relationship between different physical quantities. Let's see a question. The question says, time period of a pendulum T depends on the mass, length, and acceleration due to gravity. We have to derive a relation connecting all these four physical quantities. For that, we assume T depends on m as a power of a, m to the power of a, then L to the power of b, and then g to the power of c. Removing the proportionality sign by equal sign, a constant k comes, which is just constant of proportionality. Applying dimensions on both sides, dimension of t, time period, which is just t only, equals dimensional formula of mass. Mass is just m to the power of a. Length is just L to the power of b. G, acceleration due to gravity, has a dimensional formula Lt to the power of minus 2 whole to the power of c. Physics over math. M to the power of a remains as m to the power of a. L to the power of b remains as L to the power of b. Now L to the power of c and t to the power of minus 2c. Then bringing all the terms together, m is just a only, m to the power of a. L to the power of b and L to the power of c, together it becomes L to the power of b plus c, t to the power of minus 2c. Equating the powers of m on both sides, we will see a equals 0, b plus c equals 0, minus 2c equals 1. From where we get c as minus half, plugging it over here, b plus c is 0, which will give you b as just half, and we know a is 0. Putting all these values in our old equation, where m to the power of a becomes m to the power of 0, L to the power of b becomes L to the power of half, g to the power of c becomes g to the power of minus half. L to the power of half means root of L. G to the power of minus half means divided by root of g. Clubbing them together, k times root of L divided by g. I know the value of k is 2 pi. You may not be knowing, which is the limitation of dimensional analysis. We won't be able to know the value of constant of proportionality. Plugging on, t equals 2 pi root of L by g. We move on to another question. The question says again, time period of t of an oil drop depends on density, radius, and surface tension. We have to prove that time period t is proportional to square root of d r to the power of 3 divided by s. We go for the dimensional analysis. We write t depends on d to the power of a, r to the power of b, and s to the power of c. Removing the proportionality sign by equal sign with constant of proportionality, putting dimensions on both sides, dimension formula of time period is just t only, equals, k has no dimension, dimensional formula of density is ml to the power of minus 3 whole to the power of a, radius is kind of distance, so L to the power of b, surface tension has a dimensional formula mt to the power of minus 2 whole to the power of c. M to the power of a, n to the power of minus 3a, n to the power of b, m to the power of c, t to the power of minus 2c. Bringing all the terms together, m to the power of a, m to the power of c gives you m to the power of a plus c, n to the power of minus 3a, L to the power of b will give you minus 3a plus b, and the last one is t to the power of minus 2c. Equating powers of m, l and t on both sides, we will see a plus c equals 0, minus 3a plus b equals 0, minus 2c equals 1, from which we get the value of c as minus half. Plugging that over here, the value of a, we get it as plus half. Plugging that in this equation, minus 3 times value of a is half plus b equals 0, we can get B as 3 by 2 because this minus 3 by 2 goes to the other side. It becomes plus 3 by 2. Plugging all these values into our old equation, which gives you d to the power of a, d to the power of half, L to the power of b, 3 by 2, g to the power of minus 1 by 2. Then to the power of half means square root. So this becomes root of d, this becomes root of r cube, and this becomes root of g, but under, within the denominator. So eventually it becomes d cube r cube divided by g, everything inside the square root. T is proportional to which is given. To find dimensional formula of a constant, the last application, it's a question which says calculate dimensional formula of h. They give you the formula connecting h and so many things, where lambda is the wavelength, which is a dimension L, mass m, velocity L t to the power of minus 1. Rearranging this equation as h gives you lambda m times v. So dimensional formula of h will be dimensional formula of lambda, wavelength, dimensional formula of mass, and dimensional formula of velocity. Plugging the dimensions, wavelength is just L, mass m, velocity Lt to the power of minus 1, which gives you m square t to the power of minus 1. So dimensional formula of Planck's constant is ml square t to the power of minus 1. Another question, finding the dimensional formula of a constant. The question says y equals a sine omega t minus kx. They wanted dimensional formula of a, dimensional formula of k, and dimensional formula of omega. They tell you y is displacement, which is the dimension L, a amplitude, we had find the dimensional formula, t time, and distance L, the dimensional formula. Unfortunately, they didn't tell you what is k and what is omega, but no problem. Look at this equation. In this equation, if you see sine of omega t minus kx, sine is an angle. Angle has no dimension, so the whole step has no dimension. So this has no dimension at all, which means dimensional formula of y and dimensional formula of a are the same by the principle of homogeneity. And we know y is displacement, so dimensional formula of a, the amplitude is L. First part over. For the second part, this is angle. So angle has no dimension, which means by the principle of homogeneity, difference between two. So omega t is dimensionless. Kx is also dimensionless. Why? It is angle. By the principle of homogeneity, all should have the same dimensions. Next, what am I writing is dimensional formula of kx is dimensionless. So dimensional formula of k will be 1 divided by dimension of x. Dimensionless means it is m to the power 0, L to the power 0, and t to the power 0, which is 1. So 1 divided by dimension of x, and you know dimension of x is L, so that becomes L to the power of minus 1. So k has a dimension L to the power of minus 1. Same logic, we will go for omega t. Omega t is dimensionless. So dimensional formula of omega will be 1 divided by dimension of time. Dimension of time is t, 1 by t. T goes to the top, it becomes t to the power of minus 1. Let's do some MCQs. Dimensional analysis can be used to check the correctness of equation, true. Convert from one system unit into another one, true. Derive equations connecting different physical quantities. So all of them are true. So D is the right answer. Moving on to the next question. The quantities which can be added, subtracted, equaled in a physical equation should have same dimension. This is the meaning of principle of homogeneity. So this is known as principle of homogeneity. We move on to another question. They wanted dimensional formula of C. As we said before, dimensional formula of each term should be the same. So dimensional formula of A will be dimensional formula of X. What is X? Displacement. So dimensional formula of A is L. Dimensional formula of BT will be the same as X. Dimensional formula of CT square will be same as X. They wanted C. So I'm writing CT square has same dimension as X. So what are we looking for? We are looking for C. Dimensional formula of X divided by dimensional formula of T square. X is L T square. It becomes L T to the power of minus 2. So the answer is C. Now some ARQs. Light year, wavelength, both of them have same dimensional formula. True. Reason, both light year and wavelength represents measurement of time. No. Both represents dimensions of distance. So assertion is true, reason is false. So the answer is C. Another ARQ, the relation which we did before cannot be derived using dimensional analysis. True. Why? Sine, trigonometric functions, logarithmic functions, exponential functions, we cannot see the reason. True. And reason is the correct explanation for assertion. So the answer is A. That's all. Thank you so much.